The broadcast is now starting. All attendees are in listen-only mode.
Well, hello there, and welcome from Studio 27 in Sacramento, California, and to our other panelists from across the U.S. to today's webinar, Real-Time High-Resolution Decision Support Systems for the Control Room, Trends, Use Cases, and Best Practices for IT Integrators, Consultants, Equipment Manufacturers, and End Users. It's sponsored by RGB Spectrum and hosted by WebAttract, the leading end-to-end provider of informational webinars. Hi, I'm Mike Agron, the executive webinar producer with WebAttract. I'll be your moderator and one of your hosts for today's session, and would really like to thank you for joining us. Now, for those of you that may not be familiar with RGB Spectrum, they're a San Francisco Bay Area company, and they're a leading designer and manufacturer of cutting-edge videographic products for audiovisual, industrial, medical, and military applications. Now, shortly we're going to be hearing from our featured experts, Arndt Schrader of RGB Spectrum and Randy Pagman of RP Visual Solutions. They're going to share their insights and best practices as they explore the many operational advantages achieved by leveraging real-time, high-resolution decision support systems. Now, you're also going to have an opportunity to have your questions answered at the end of our panel discussion, and I'll get to that in just a moment. We're really delighted that we have such a wide, diverse audience, and as you can see, we've pulled folks from all over the U.S., and we really appreciate you taking the time to join us. And from an industry perspective, we've got quite a diverse audience. We've invited you, along with other professionals from some of the industries that you see on here in transportation, energy, security, emergency management, public utilities, military, and telecom. But we believe regardless of your role or your industry affiliation, you're going to find today's webinar of value. Now let's move to our first poll. We have a very diverse audience, as you can tell. I'm now going to launch this poll. And if you would be kind enough to tell us, to help us focus our discussion, which of the following topics would be your primary of interest? Choose as many as you like. Would it be industry trends? Would it be about use cases? Would it be about best practices? Or some of the latest video solutions for facility security and observation? Go ahead and take a moment and do that, and then I'm going to bring up our panelists. And let's share the results. So, gents, as you can see, 52% of the audience is interested in industry trends, 34% on use cases, 62% on best practices, and 55% are interested in the latest video solutions for facility security and observation. Thank you very much, audience. That's very helpful. So, let's get started, and let me give you a brief introduction of who our panel of experts are, and then I'm going to turn it over to Arndt. Our special guest is Randy Pagman, and he is the president and owner of RP Visual Solutions, and he's been involved in the audiovisual display industry for almost 3 decades. His company, RP, specializes in designing and fabricating innovative, customized visual displays. He's also recognized as one of the premier educators in control room design and projection screen technology. He has a course called Take Control of Command and Control Rooms that he presents annually at the Infocom trade show, and he always receives rave reviews. So we're delighted to have Randy here. Also, our host from RGB is Arndt Schrader. Now, Arndt's the project manager for RGB Spectrum, and his main focus is on multi-point KBM solution, and that's a decision support system for control rooms. That launched in 2010, and prior to that, he held senior product management, product marketing, and business development positions at prominent telecommunications equipment vendors, including Ericsson, Tandberg Television, and Calix. We're absolutely delighted to have these gentlemen join us because today's webinar is devoted to providing you with insights into the trends and use cases of what's going on in the industry. So with that, Art, welcome to the webinar, and I'll turn it over to you.
Yeah, good morning. I'm delighted to be here. We just heard there's a very diverse audience, and there are quite a few questions that were asked, and ranging from I would like to hear more about decision support systems to best practices. So we'll do our best to address all of these issues throughout the presentation. The presentation is structured actually into 3 major areas. We'll talk about opportunities first, then we'll talk about the markets, and then we'll talk about the trends. And throughout these 3 sections, we will do our best to address all the issues that you have raised and all the questions you may have.
Thank you, Art. Randy Pagnon here. In front of you right now, the presentation on the slide that you see there, what we're hoping to accomplish today is to provide an insight to what we're referring to as command and control room, but in particular, taking a concept that you see here graphically depicting operators in a room, viewing a large area map. This project was circa 1980 and was actually the Tokyo 911 dispatch facility, which still exists today and has gone through multiple revisions and updates to the technology, which we'll talk about. But we're here today to take this concept and help bring the tools to bear to turn it into a reality. And what you see here now is reality. This picture actually has been updated since. This was done by Hitachi, and now subsequently has been updated in different display technologies moving forward. First, though, what I would like to talk about is to make sure we have everybody on the room is to talk about the opportunity. And we'll also speak briefly on markets and trends. So the opportunity to make sure that everybody on the phone here is together on this, I'd like to define from our perspective a control room. And a control room is, for the purposes of the seminar today, when you're remotely monitoring an asset utilizing a display technology larger than 20-inch diagonal. And it's fairly generic and all-encompassing, but due to the audience that we have here today, the asset that you're monitoring is very wide and in some cases very narrow. For example, the bandwidth on a freeway may be the asset for those of you that are on the phone from the transit marketplace. For power utilities, the asset could be 34 kV transmission lines. For military operations, it could be resources being deployed. For power, gas, utilities, each asset is different and particular to those, and the needs of those are different. The technology is very wide encompassing. You could have a single operator on a single screen, and that would be defined as a control room. In this purpose here, we're mainly looking at overview displays. 2 distinct applications, EOC, Emergency Operation Centers, and NOC, Network Operation Control Centers. Primarily today we're going to be talking about NOCs, but there's a big rise now today in building of EOCs. What's an EOC? An Emergency Operations Center may be deployable, may be pushed out of the back of a C-130. Typically the crisis ends in the case of Katrina or Haiti. May not be, probably is not 24/7. It will be a finite time and normally incorporates multiple disciplines from the world of audiovisual, being teleconferencing, audio, graphics manipulation, and display technology. Network operation control centers, and what we're mainly going to focus on today is NOCs, are fixed installs. They're facilities that are built. They're built so that the crisis never starts. Hopefully there isn't a disruption to the grid. They are, in most cases, 24/7. There may be down periods, but the displays and the operation and the operators are typically populating the facility 24/7. And the technology disciplines are usually limited to fewer than what you would say in an EOC, and typically display technology, graphics manipulations with a little bit of audio. Command and control room requirements have really migrated rapidly in the past 5 years from what you saw perhaps 20 years ago. And what people expect today when they're designing and laying out a control room is to put it in virtually any amount of high ambient light. In the olden days, just 10 to 15 years ago, display technology was of a brightness such that you did not, you had to consider lighting and ambient lighting. Today, technology is such that it's very bright and can take hostile lighting environments, so designs are now coming out of the closet, so to speak. Human factors and productivities due to graphics manipulations of products such as RGB spectrum, the ability to zoom and take images and complementarily display them up on the large screen allows you more human factors and productivity. This is my personal favorite. I used to not get along well with architects who would design a control room and then give me a 12-inch rear projection room. RP Visuals, the RP stood for at one time rear projection. We've migrated quite a bit. But limited real estate space is really a challenge as that new display technologies, be it flat panel, TFT, LCD, new LED DLP technology, and MicroTile and laser phosphor displays are all a much narrower footprint. Technology today is also much easier to maintain, and I have had the opportunity to look at the attendees today, and I was quite pleased to see that there's some AV specialists on staff, because it is migrating now, the technology, to much more IT-based. And now we don't typically have an AV specialist responsible for maintaining the AV systems. Quite often that is becoming part of the IT infrastructure. Cost to maintain, though, is a major buy decision factor. And you need to run the numbers such that to see what each of these different display options we talk about will cost in the world of cost to maintaining. In the world of IT, I'd like to turn it back over to Art to talk about effective use of the wall.
Yeah, and all these beautiful displays that we have today, multi-tiled walls, also drive a need for a processor that actually drives these displays in turn. How do I get a window actually full screen across, let's say, 12 screens? How can I move a window across Mullion? How can I, for example, KVM into a certain window and affect the sources behind that? How can I zoom into certain windows? Special effects. Those are all things accomplished by the display processor. There's another trend, actually, and that's to have, and that's mostly centered on the operator, actually. There's a need to have any video or graphic available anywhere, anytime, from anywhere. That's really the idea behind decision support. So again, a single operator, for example, sitting at his desk with a keyboard and mouse and trying to operate, let's say, a 1:3 display in front of him, as well as a wall, as well as maybe remotely KVMing into another asset. So for those of you who are integrators and planners, this is an attempt to size the market. We believe it's between $750 and $1.25 billion worldwide. This includes all the technologies that really go into the control room. So anything from the IT routers and cabling to consoles, to displays, to display processors, to software, to KVM technology, so the entire gamut of technologies. And to give you an idea as to substantiate this market size here, one of the companies active in this market actually published quarterly results, and you see they had $100 million in sales in monitoring, control, and medical. So if you use that and try to estimate their share of the market and their revenue on an annual basis, assuming that they have a fraction of the market, you will roughly come to the $1 billion mark as an estimate of the overall market. Yeah, so the idea is to keep this presentation as close to the actual applications as possible, because many of you actually had questions. What are the applications? What are the markets? And what does it mean for the technology that I'm trying to deploy in these markets? And there are 5 major market segments. There would be the transit system, train systems, for example, metro systems. You would have municipalities, would be fire, police departments, utilities, which could be subdivided into power, telecom, and oil and gas. And oil and gas mostly today would be from an exploration standpoint. Then security, and what we mean here is actually physical building security. And then the other segment would include government, military, and financial institutions. And Randy will talk about transit systems in detail.
Now, I do want you to appreciate that each one of these markets has a sub-segment, as you'll see on the next slide here. Transit, municipalities, utilities. If you see here on the transit slide, this is actually LA County TMC. And the transit world, just speaking transit, because we're not going to have time to go into the other industries as much, has sub-markets such as intermodal, light rail, traffic and signal, airport transportation, could also be bridges, shipping. Transit for each one of those markets, and what you're seeing here with LA County TMC, is graphics and video and data manipulated over a 2-high by 7-wide cube wall. And therefore it's graphics that are complementing the operators sitting there doing their job. So one mistake you want to avoid is simply amplification of the data in front of you. You want to take data and convert it into a graphical format. The graphics that you might see in transit systems are most affected by weather. And this is just simply to show you that transit quite often is affected by weather, and then you want to see the effects. So you have a high amount of video insertion and needs for video graphics typically in transit systems, and RGB spectrum has the ability to insert video, manipulate video, and as Art will talk regarding KVM, insert it in different formats into the application. For each transit system subsegment, so for intelligent traffic systems, there's ITS America. And each one of you on the phone from an integrator standpoint, you could check out each one of these websites. And each one of these organizations typically also have a trade show, the Intermodal show, the ITE show. All of these have specific needs and applications that are very different. If we have any Canadians on the phone, Welland Canal, monitoring the St. Lawrence Seaway, obviously the graphics there of moving a ship up and down is not quite as dynamic as what you might see on the I-5 freeway at rush hour.
Yeah, so this slide actually shows a traffic monitoring application. So on the bottom you see source computers that actually run the different applications that are needed. The main application would be the video monitoring and management application, but there's also word processing, there are transaction type systems that actually need to be accessed. Especially the video monitoring systems are typically multi-head computers. So you see here these signals actually go at DVI out of the computer and are switched actually in DVI format to any of the screens. In this case, they have 3 operators. This is also trend in traffic monitoring. There are fewer traffic monitoring centers nowadays, increasing the traffic and the video, decreasing the number of operators, and therefore actually making operators more effective. At the same time, they have to do more with less, which is where the KVM and the single point of control actually comes in. You can see here, for example, each screen, each operator actually has 2 screens, so each screen is fed by a separate DVI signal. And why did they choose DVI for distribution? Well, it simply gave them the highest resolution. There's no delay. There's no reprocessing of video signal that actually has to happen. Therefore, the greatest flexibility.
Next, very exciting, I'm pleased to share with you that picture you see there on the screen right now. That's on Sound and Video Contractor, which is a major publication for our industry. And that's the front page of the just released January magazine. And quite interestingly enough, that is also an RGB rear projection, or excuse me, an RPV rear projection wall and an RGB spectrum product that is driving that wall. That is LA EOC. That's a new facility in downtown Los Angeles that is consolidating 911, police, fire, ambulance in a crisis all under one roof. There's actually 7 control rooms in that facility. And that's the first floor, which is really interesting because that's 2 by 2, 137-inch diagonal rear projection command wall, which requires more space than some of the newer technologies. Upstairs, there's a mirror wall, which is almost identical to that, and that is a 4-high by 7-wide TFT LCD monitor mount. So just the evolution of technology in 2 years has been quite significant in that same facility. That's for municipalities. Graphics that you might see on municipalities, if I can have the next slide, utilities now. Utilities are broken up into major markets. This is for a power utility, and what you're seeing here is actually transmission. This is Hydro One in Toronto, and this is 2-high by 20-wide matrix rear projection wall where each screen is 72 inches by 96 inches. So you have a very high, 12-foot high image spread over a very long, wide field of view. That is for transmission, which again has its own particular show and trade show and organization. Above that icon is distribution. Next week, Distributech is in San Diego. For those of you on the power utility world, that's in San Diego. And that's an annual show where 6 or 7 manufacturers, including RGB Spectra, will be showcasing product at that show. And the top icon is generation. Obviously, generation is very static and not as dynamic, be it nuclear, hydro, thermal, as transmission may be. And then probably the most dynamically changing and is tied to the grid changing is distribution. So it just gives you an appreciation. But the graphics you see on there are from a SCADA system, supervisory control and data acquisition, remotely monitoring the network, the grid across Ontario. Now, SCADA graphics. This is just a clip art, I believe, off of ABB. SCADA systems advanced quite a bit lately where you can typically purchase a graphical user interface that allows you to take the data that's inherent in the SCADA system and present it in a graphical format such as this. Humans can assimilate graphics way quicker than they can assimilate data, but the limitation on this is usually that it's limited to 1 screen output, perhaps 2, maybe 3. Hence, RGB Spectrum's products allow you to take that graphics and manipulate it and split it over many different outputs to give you a dynamically reconfigurable display surface.
Yeah, and especially in the distribution segment of the power utility market, there are actually some interesting developments. For example, smart meters are being deployed right now in most regions of the country, driving actually the need to display more data. Then SCADA itself traditionally actually has been very low in terms of refresh rates. Sometimes the screen would refresh every 30 to 60 seconds. And that mostly had to do with the data architecture that was used to distribute signals. And so there is a need, and then geographic information systems. So the idea of actually overlaying where certain households are, where certain drops are, where certain transmission lines are onto a geographic map. So all of these actually drive the need for more advanced display technologies.
On telecommunications, the slide that was just up on, that's Rogers Cable in Canada as well, and that is 3 banks of video walls, each 2 high by 6 wide, 50-inch diagonal displays with graphics and being manipulated overall. Telecommunications spans the wireless, cellular, satellite, cable, ISDN marketplaces, and why we identify this as a separate marketplace is it tends to be early adopters due to the deregulation. Telecommunications at one time was the biggest single control room market, but that has changed that it's not such that today that all utilities are utilizing visual display in control rooms.
Right, and especially the fact that, for example, now AT&T offers video and internet services. Traditionally, all they did was voice, so there's a need actually for a much advanced control room architecture. So when it comes to utilities and oil and gas exploration, that's an interesting market. Especially oil and gas exploration is mostly done on ships, and these vessels actually go, of course, across the Atlantic, the polar caps, wherever they go, and they believe there's some oil reserves to be found, and they collect a lot of data and they collect a lot of graphic images as well. On the bottom right, you actually see a typical control room in that environment. And there's a need, again, for a few operators to control all these screens and evaluate the data. A lot of switching actually takes place in this environment as well, where you want to bring images that are on a local display up on a more central screen where they can be viewed from many operators at the same time.
A very rapid growing market is a lot of federal funds are now finding its way through to the security and surveillance. We personally have been involved in projects with the CIA, FBI, and Department of Homeland Security within the last 6 months. High demands on video manipulation and surveillance, be it in different formats. If you can get the video into a centralized, then you can display it in an intelligent output. This graphic's just to show that in this application you have a high amount of both data graphics, but a lot of video integration, a lot of real-time streaming video in different formats to be displayed.
Yeah, and this is an example of a typical security operations center. There's an interesting trend in this market, and many of these centers nowadays actually are regional, meaning they have, let's say, 800,000-900,000 camera feeds coming in from 100, 150, 200 miles away from different locations. And also nowadays you have megapixel cameras with 2 megapixel, 3 megapixel even, that are often used for these applications. They're especially interesting because they offer high resolution and face recognition, as well as maybe a number plate recognition of a car. So this detail is often desired. Also, there are many applications that are used that run on separate systems. You would have the security system management. You'd have GIS often, which would be a central display where cameras and camera angles actually are displayed on a overlay map. You'd have communications and word processing. You have the wall control. Often you have also streams coming in from local TV stations for weather and news. So again, there's actually a need here to control many applications, many computers from a single keyboard and mouse.
To speak on trends, I'm going to talk about display, and then Arndt's going to talk about processor and decision support.
Yeah, so this is simply an attempt. I mean, for those of you that actually know the dictionary.com website, really found this way of presenting trends quite intriguing. They use it for antonyms and synonyms, obviously. We kind of borrowed the idea here. The trends mostly center on security considerations, video and graphics, the operator, and data. And Randy will focus on new display technologies, and then I will focus on the trends that I feel pertain to decision support systems.
So I think our itinerary says that I've got about 8 minutes, and I'm going to cover the world, and I'll do my best. But for starting in about 2006, 2007, there was a lot of exciting new technologies that started making its way out into SMPTE and SID shows, and those products are now finding their way into the network operation control centers. And I'm going to speak briefly on some trends that we're seeing from an RP visual standpoint. The world traditionally was 4.3. Today it's 16.9, 16.10. All the major manufacturers that play in this marketplace now are offering 24/7 control room products specifically built in a 16.9 or 16.10 aspect ratio. So what does it mean, a wider field of view versus a 4.3? Rapid deployment of thin Mullion LCD. Samsung's glass that came out, the 46-inch TFT 1366 by 768 glass, with very tight mullions unseen until 2-3 years ago, has allowed architects to design these into control rooms in spaces you might not have seen them before. Energy efficiency, everything's becoming LEED certified. It's a real key design criteria that many architects are going to have to solve for. Intelligent displays, all the major manufacturers, trying not to mention names, but some of the major players in the 24/7 world can all remotely monitor their displays virtually anywhere in the world from a centralized station, and know when lamps need to be changed and when technology needs tweaking. Front screens. Everyone wants to do a front screen control room, but because of ambient light it wasn't good. So is there a solution there? Yes, there is now. I'm going to talk briefly on 2 new display technologies. One is referred to as LPD, laser phosphor display, and one is MicroTiles. Both of those are brand dependent, or brand analogy with Prism for LPD and Chrissy with MicroTiles. And then also future safe control room designs. Just talk about one of the oldest, most prestigious control rooms that has gone through major updates. So in the world of 16.9, Clarity, Barco, Christie, and Clarity now Planar, excuse me, are all playing in the world of 16.9, 16.10, both in rear projection cubes, as you see in the top two pictures. Mitsubishi's also a player here, and also the world of projector light engines for the control room 24/7 applications. And Barco, you see here at the bottom, NSL 4601 is their answer to TFT LCD. The natural field of view is wider than high. Unfortunately, many people on the phone, your grids are higher than wide. Most cities, San Francisco, Los Angeles, tend to run north-south more than they run left-right, and that becomes a bit of a design challenge in control rooms. Rapid deployment thin Mullion LCD. There's 7 or 8 major manufacturers now remarketing, and I'm just trying to spread the wealth around here, but this is Planar's answer of the 46-inch TFT. Again, it's built by Samsung, marketed by Barco, Mitsubishi, Planar, Kira, L-Port, a couple of those just to name a few. You end up with a very tight seam between images, and these are 24/7 rated. Very key design criteria now is energy efficiency, and I am touching on all of these at a very high level, but suffice it to say that traditional rear projection is mercury-based, mercury lamps, and the lamp in there may give you 2,000 hours. It may give you best case 8,000 hours, but it is a consumable that will have to be disposed, and it has to be disposed safely. LED technology, which all the major manufacturers are offering an LED solution now, are mercury-free, lead-free, and as opposed to 2,000 to 8,000 hours, most LED-based systems are getting 50,000 hours. What does that mean in your cost to maintain? Well, in a 24/7 application, there's 8,760 hours per year, and if you're leaving these illuminated, that just went from needing 4 lamps a year to needing 1 illumination system every 4 to 5 years. So significant changes, ROSE compliant. This is becoming much more of a hot button in the design up front. Auto calibration. Barco has a system such that allows you to auto calibrate the panels and then also remotely monitor them. So you can get feedback from each individual panel. And to make sure everybody's with us, the little picture you see on the left there, that is a 2x2 array. That is 4 panels making up 1 image, split over the 4 panels, and then the device on the right is an auto calibration cup that senses the uniformity and brightness and allows the display to be auto calibrated. Is front screen possible? Well, this is Vandenberg Air Force Base, and if I showed you the before-after picture, you would be not sleeping well at night if you knew that's how they're launching missiles at the bad guys. This is now DNP's Supernova, and what you see here, and what I want to point out is we've taken the operators out of the dark, so to speak. Those fluorescent lights are hostile light. They spread light everywhere. This new optical front screen technology is directional. It sees the projected light from the projector, but it rejects the ambient light from the room environments and or windows. Works spectacular when you have off-axis lighting. Doesn't work so good if you had lighting coming from the same source as the projector, but in certain control rooms, this is an absolute great technology to consider, whereas in the past, I would not be sitting here talking about front screen in a control room. Okay, some exciting new technology. Everything's getting smaller. This product referred to as MicroTiles. I like their catchphrase of a digital canvas. I've always used a dynamically reconfigurable display surface. This product, if I can have the next slide, allows you, each one of these little tiles is 12 inches by 16 inches. And we are currently doing an installation at New York Police Department of 1,180 Christie MicroTiles, and the picture you see here is one portion of the command wall, which is 8 by 45. Why this technology? Well, you only need 15 inches of depth from the front to the back. You can service it from the front. It gives you a high amount of resolution. Each one of these tiles is 540 pixels high by 720 pixels wide. This is, without question, one of the highest resolutions, densest walls you'll see. This is NYPD's EOC version of what you saw earlier at LA EOC. So they are using this technology in a control room environment, both for EOC and also for NOC, 24/7 application. Now, this picture I just got recently on a project that's going on back on the East Coast. So we talked about these different technologies, and this is a shot of some customer back east evaluating LED DLP, which is the MicroTiles in the top left you see there. And so there's an array that is 4 tiles high by 6 tiles wide. And then we have PDP plasma, which I would not recommend in a control room due to 24/7, but maybe in an EOC. That's 42-inch plasma, and those are 858 by 480 resolution with a 1.5 millimeter seam between images. And those are plasma in a 2x2. Down below in the bottom left, you see TFT LCD. That should not be LED, excuse me for that. It's TFT LCD, migrating now to LED backlit, but for 24/7 right now, most of it's still LCD, and that's 46-inch, and that's 1366 by 768 each panel. And then the new laser phosphor display technology from Prism, which is a Northern California-based company, and these are 20-inch diagonal displays, and the resolution on these is 320 wide. I thought you'd find that shot interesting because that is different options now being considered in control rooms. Just to wrap up on trends in display, this is for those of you on the phone that know control rooms, everybody knows this shot. This is AT&T Bedminster, and this room has been commissioned in the early 80s and has gone through 5 major display technology advances while all still staying in the same environment. So people point to this room for future safeness. Those of you on the phone from power utilities, you're used to a map board lasting 15, 20 years because your grid didn't change much. Well, now things are changing quicker, and this room allowed for that. I like to also talk about this and to turn it back over to Arndt because this had the largest dynaire switch, a bunch of inputs, a bunch of outputs in the world. This had a room of dynaire switch. Dynaire has gone away. This has had new updated display manipulation technology put behind this wall, and again, future safe is becoming a key design factor. Just to wrap up, some other cool stuff, and we don't have time to talk about this, but blend screens. The top 2 pictures show you 3 projectors being blended seamlessly. Take that blend screen technology, made it with the bottom left picture, which is interactive touch, and you're almost back to the olden days where you could get up and interact and touch an old tile board or move a magnetic board around. And it's also colliding rapidly right now with 3D immersive, which is the picture in the bottom right. There was a job done 2 years ago now at Sandia Labs in Albuquerque, New Mexico with 48 3D projectors, but it was a monitoring process control facility, so it gives you ideas of what they might be monitoring and controlling in that environment. I'd like to turn it back over to Art now for processor and decision support.
Yeah, before I do that, I'd also like to comment on the AT&T slide briefly that we saw before. It's an excellent example of how a control room actually can be used to market the abilities and the capabilities of your company. This would be probably, if I were a visitor at AT&T and if I were allowed into their headquarters there, that's the site I would want to see. And many other companies actually use the control rooms for this purpose as well. It's a marketing vehicle in many cases, showing off, excuse me, the competency of the company. So talking about the industry trends as they pertain to the decision support system, there are a few that stand out. One of them would be higher quality. We talked about megapixel cameras. So there is a need to display higher quality imagery. Efficiency is another one. Operators are forced to do more with less. So if you design a system, keep efficiency in mind. Flexibility kind of goes with efficiency, but the idea here is that a control room should be built around the operators and the organization's needs rather than technology actually defining what the operator should need. And then when it comes to data, more and more data is coming our way nowadays. A good example would be the telecommunications market that we talked about before, the utility market with the smart meters, again driving the design for the decision support system. This is an example of an IP implementation. And I just wanted to briefly talk about the shortcomings of some of the IP implementations that we see nowadays. Most of the video traffic that is coming in, first of all, IP is not really meant for video traffic. When IP was designed, it was built around data. So we're using an infrastructure that is and repurposing it for video. Most of the video that's coming in actually is VBR, meaning the bandwidth actually spikes if there is increased movement. And because of that, if you want to keep a quality consistent, you actually have to plan for about 40 to 60% of the capacity of the network to be empty, so that the streams actually can spike. Lower quality video is often a concern because you have to encode and decode. There are quite a few MPEG-4, H.264 is the dominant codec nowadays, but it has its problems as well. If you really wanted to have a high quality, almost not distinguishable signal versus a raw signal, you would have to be in the 25 to 30 megabit per second range. Processing delays are often introduced in these systems as well because of the decoding and the re-encoding, not to mention refresh rates. As I mentioned in the SCADA example before, the refresh rates are often in the 30-second to up to a minute range. DVI actually can work around that. So what did we do? Next slide, please. We came up with a hybrid solution. It uses the IP infrastructure for what it was meant for data traffic. So the KVM control signal traffic is sent over the data network, and the video traffic is sent over the DVI network. So we have a solution that offers collaboration, meaning you can hand off control to another operator. As I said, it functions over the DVI infrastructure, so you can actually display high-resolution, uncompressed graphics and video. What comes out of your computer can be routed to a display. There are no ifs or buts. We also focused on easy navigation. The system can be learned rather rapidly within minutes. We've had testers here to test our system with probably less than adequate computer skills that picked up the system in, I would say, 20 minutes to half an hour. It was not a problem to navigate. It's also integrated with many display processor options, such as the wall and the view products. Next slide, please. This is an architectural diagram. The green actually depicts the Ethernet traffic. The red lines depict the DVI, which is used for video. And as you can see in the top right, there will be a video wall display, meaning basically that you can have multiple sources or multiple windows distributed across multiple screens. In the middle, there's a view display, which simply means you have multiple windows within a screen. And on the bottom, you have a 1x3 desktop configuration. Now, you can really mix and match many times. A multi-view type display would be used as an operator display, and the wall often is, of course, used as the central display. And the navigation, I just wanted to highlight that here is really simple. Mike, if you would click the mouse or would advance one more time, the mouse actually will move. What you're doing here, simply by moving the cursor from one screen into the next, you're actually taking control of the associated computer. So it's very intuitive, it's easy to use, and the processor control is really immediately at your fingertips. There's no switching. All the switching is embedded in the system. It happens behind the scenes. So it's really, for those of you that know how to use a multi-headed computer or simply have additional monitor hooked up to your laptop or your desk, that's really how the system operates from a user standpoint. Next slide, please. There's also the switching and collaboration actually integrated. You simply move the mouse to the edge of the screen, and what you see under step 2, the panel would actually come up, and you can simply route to whatever source computer you would like to route to. There's also an access hierarchy built in, so if there's a commander who needs to take control of a control station, he can do so without notice. So I wanted to thank you for listening. I hope we addressed most of the questions and most of the interests that you had. And I'll turn it over to Mike at this point for a Q&A and follow-up.
Thank you so much, Arndt, and you too, Randy. Great job, gents. Great job. A lot of great information. And we have some questions in the queue. The first one is from Mike H. With advances and cost reductions in consumer-grade displays, LCD, LED, flat screens, are you seeing operators installing more of these as off-the-shelf displays as opposed to true control room-rated commercial-type displays? Randy or Arndt, either one of you can take that.
I'll take that question. There's always been bad control rooms done. Back 20 years ago, you would see quite often an LCD projector, which would be a consumer-grade projector put in there. And there's always an argument to be made that, well, yeah, it's not 24/7. And, hey, buying 4 of them is cheaper than putting in one 24/7 rated projector. You know, my response to that is with the advances with LED and in particular being much more stable, I think you're going to start to see some consumer-grade products come into control rooms, but I wouldn't want to be the early adopter. I wouldn't want to be the one making that buy decision, not when I'm monitoring my critical 24/7. So I would still very strongly advocate that you remain in the camp of 24/7 related display products from 24/7 related manufacturers. And again, you could see back in the 20 years ago, consumer-grade displays going into control rooms, but I would not recommend that or support it at this time yet.
Thanks, Randy. Art, did you want to add to that?
No, I think Randy did a great job answering the question.
Great. Here's the next question from Don C. Are the large format displays being shown single displays, or are they knit together from multiple independent screens? And the second part is, are the displays interactive, and do they support drill down? So if you need me to repeat any of that, just let me know.
This one we'll be answering together, Arndt.
Yes.
You will see a single display control room, and in which case there's very little opportunity for both of our companies' expertise. I mean, RGB has a SuperView windowing product that you would want to be doing a reverse matrix. In other words, you could open up multiple video windows in a single display, and it could be a single large area format display. Typically, the output technologies are going to be limited to a size such that if you have a single operator, you might have a single screen. If you get into a larger area, a single screen from a lot of human factors, closest view or furthest view or pixel density, is going to warrant that you go to a matrix, as you called it. And in a matrix display system, different products from RGB for the computer wall, different disciplines from RPV from a custom fabrication standpoint. There is single screen control rooms, but it seems to be the few, not the norm.
Yeah, I would actually agree. I just, from talking to customers, from from judging by our installs, by judging what I see out there, the most common display configuration probably is a 2x2 up to a 3x4 display configuration with multiple windows or source computers actually distributed across these screens. And as Randy said, if there's a single one, a single monitor, that typically is for small applications. We see that sometimes in the military. We see that in the medical field. But if you do that, you typically do not have a fully fledged decision support system driving these displays and driving the control center.
Now, that second part of the question was interactivity, and the answer is yes. How you interact is migrating and changing. So interactivity, RGB has some nice products that allow you to interact multiple meets over multiple displays, and you're operating and manually doing that from your desktop. I am starting to see interactive touch, be single touch, dual touch, or true multi-touch. We're in the early adopter stage of control room display systems starting to become interactive touch at the output place.
Great. And the last part of that question, and gentlemen, I can't remember if you answered it, was do they support drill down?
Drill down, I can probably answer that. I assume you mean a type of zooming ability, and yes, our display processors actually support zooming. It's done with your keyboard and mouse. It's very simple to use. I can do it.
Thanks, Arndt. Randy, here's one from Peter. What are the current and future situational awareness developments around integrations with mobile field apps? Could you answer that?
Well, the fantasy, of course, is always to deploy knock in a box, Network Operation Control Center, EOC, and a flight case out the back of a C-130. I'm not sure if that's what they're asking. Obviously, as the display technologies are becoming more Legoland friendly, be it TFT LCD, be it the matrix panels from MicroTiles or LPD, they are designed to be assembled in arrays that are configured how best to suit the output. We're closer. There's still a lot of issue and concerns over ruggedization and transportability that make it difficult to truly deploy. Most mobile apps, frankly, still are of the front screen environment that I'm aware of, and it's just that they're easier to push out the back of a plane.
I'd like to add to that, actually. When you do field surveillance, for example, you typically have very, very high-resolution cameras to actually zoom into the battlefield. And this typically drives a display for a need for a high-resolution display. At the same time, Randy is right. You don't have the ability to set up huge walls. So our walls, actually, our display, are used in the two major wars right now for the situational awareness application.
Well, here's one of the last questions before I give some housekeeping. This is from Bob. Bob says, I believe these type of solutions would deliver tremendous value to my company, but I need to know how to build a business case to convince my manager that this is the right way to go. Can you give a couple of examples on some things to think about around ROI or whatever metrics you'd use, gentlemen?
You or me, Arndt?
I can go. I mean, the major metrics, I think, here is the cost of ownership over time, over a period of, let's say, 5 or 6 or 7 or 8 years. And then you would obviously have to compare that with some of the other technologies that you're considering. The best driver, of course, for ROI is what is it that actually I'm trying to monitor, and actually can I live without monitoring what I'm trying to monitor. So, for example, if another gas pipeline blows up in south of San Francisco, the obvious answer there would be you can't afford not to monitor and not to monitor correctly.
Arndt's answering the question from an end-user customer perspective. I'm not sure the source of the question. I would address it from a manufacturer integrator. The metrics are such that the number that Arndt spoke of, everybody debates the $750 million to $1.25 million, but there is no debate that there's integrators in North America now that have separate and focused control room groups, so there's a business there. There's all the manufacturers now, all the major manufacturers have separate and dedicated control room marketing and sales staff, so there's a business there. If that's who's asking the question, there's metrics and numbers that would make a business case for focusing on control rooms.
Thank you, Randy, and thank you, Arndt. And folks in the audience, I want to thank you all for joining us today. It's hard to believe we are almost at the end of the hour, but we do appreciate your interest and want to let you know that you will be receiving an email shortly with a link in it to have your own on-demand viewing of today's webinar. You'll also have information on how to continue the discussion with either RGB or RP Visual Solutions. And last but not least, there will be a survey that will pop up in your browser. We'd really love to get your feedback on that. Most importantly, we want to thank again Randy for joining us today, and Art and RGB for hosting today's webinar. It's always fun to do these. And as your moderator, this is Mike Agron saying thanks so much for joining us. Have a terrific rest of the week, and bye for now.